Hi everybody, how do you do? We are from Hematology Division of Airlangga Clinical Pathology Department. Today we will talk about the morphology of erythroid cell. We thank Dr. Yeti, Dr. Ariful, Dr. Paulus, Dr. Ferry, Dr. Sari, Dr. Fitri for providing the material for this lecture.
Information technology system has developed rapidly and makes everything easier to be accessed without any borders. E-learning is the way forward for quality education in today's world. Hopefully, this learning session would improve students' knowledge about erythroid cells and its abnormal morphology. In this learning session, we will focus on the erythropoiesis series. Here's the maturation stage of a erythroid cell. Start from the most immature form, which is pronormoblasts, then the besophilic normoblasts. After that, the polychromatophilic normoblasts, then the orthochromic normoblasts, and last but not least, reticulocyte. Pronormoblasts are also named as the proerythroblasts or rubriblasts, is size 12 to 20 micrometers with round to slightly oval nucleus. It has 1 to 2 nucleoli with fine chromatin and dark blue cytoplasm. The besophilic normoblast is also called as besophilic erythroblast or prorubrycyte. It is size 10 to 15 micrometers with round to slightly oval nucleus. It has 0 to 1 nucleoli with slightly condensed chromatin and dark blue cytoplasm. The polychromatic normoblast is also called rubricite. It is size 10 to 12 micrometers with rounded nucleus. It has no nucleoli, however, it has condensed chromatin with pathogenomonic cartwheel phenomenon and gray bluish cytoplasm. The orthochromic normoblast is also called metarubricite. Is sized around 8 to 10 micrometers with rounded nucleus. It also has no nucleoli. Its chromatin is even more condensed than the polychromatophilic one. The cytoplasm is pink or salmon rather than blue. We can see number 1 is the besophilic normoblast. Number 2 is the polychromatic normoblast. Number 3 is the orthochromic normoblast. The red arrow shows internuclear bridging between besophilic normoblasts, which is commonly found in MDS. Next is the besophilic erythrocyte, or we usually call it reticulocyte. It has no nucleus and the cytoplasm is blue or purple. In Giemsa stain, reticulocyte seems larger than the other erythrocyte, without any central pillar, and more polychromatic. The last development is mature erythrocyte. In blood smears, we should examine the size and the chromasia. Erythrocyte has specific characteristics, such as biconcave, a central pallor around 1/3 of its diameter, and it is big as the nucleus of a small lymphocyte. This is an example of a normochromic normocytic erythrocyte. Compare its size with the lymphocyte's nucleus. In this picture, we can see a hypochromic microcytic erythrocyte. Notice the central pallor is more than half of the erythrocyte's diameter. There are many various abnormal morphology of erythrocytes. These red arrows point fragmentocytes. In this picture, we can see number 1 is the target cell, number 2 is the teardrop cell, number 3 is a Burr cell, number 4 is a microcyte. Number 5 is a normocyte, and number 6 is a hypochromic erythrocyte. Number 7 is a normochromic erythrocyte. Number 1 is a spherocyte. Number 2 is a teardrop cell. Number 3 is an ophelocyte. Number 4 is a polychromasia cell. This is a picture of Ophelocytosis. In this picture, we can see macrocytes and ophelocytes. Notice the acanthocytes, Burr cells, and microcytes in this picture. See, these are bite cells. Top picture shows agglutinations, left bottom picture shows sickle cell, and right bottom show rouleau formation. There are some erythrocytes inclusion that we can see with right GM stain, such as Besophilic stippling, Howell-Jolly bodies, Cabot ring, and Pappenheimer bodies. If we use supravital staining, we can see Heinz bodies and hemoglobin H, which looks like a golf ball appearance. In the first picture, the red arrow showed Cabot ring, containing mitotic spindle remnants. In the second picture, the red arrow and number 1 shows a Howell-Jolly inclusion in containing DNA fragments. In the third picture, the red arrow shows basophilic stippling, containing mitotic spindle remnants. And in the last picture, the blue arrow shows Pappenheimer bodies on right stain. Multiple basophilic inclusions located peripherally on the cell. The Heinz body inclusions contains denatured hemoglobin. The red arrow shows HBH inclusion or golf ball appearance on beta 4, commonly found in HBH disease. Thank you.